Good day, everyone. So we are going to be putting a pause to our um blob storage series, and today we are going to be doing something new. We'll be looking at table storage. If you can recall, I told you that we have four different categories of sub-services on that storage account. I said we have blob storage, we have table storage, we have file share, as well as queue, the queue service, the storage queue service. And I explained that in the case of blob storage, you are talking about your objects. So things like your images, your videos, your text files, your binary files, they all fall under the blob storage. But today we are taking a step forward. We are looking at table storage. And this is where people find it difficult to have a clear line between the different categories of storage that one can have. So when we are talking about table storage, we are still going to open Visual Studio. We are still going to go to the Azure portal. But before we do that, I just want to lay down some fundamental explanation around it. So let me share my screen. Let me just go to the Azure portal, even though I wouldn't be working on it immediately. So when we talk of databases, so even though it's called table storage, it's not an SQL type of database. Even though we know when we are talking about SQL, when we are talking about SQL Server or MySQL, we usually talk about data being arranged in tables. However, in this case, when we speak about these tables, we are looking at a NoSQL type of data. And I will shed a little bit of more light to it. So when we are talking about databases, before you decide the kind of database that you want to use, there are some key considerations that, so let me not even call it database, before you decide the kind of storage architecture that you want to adopt, there are different key considerations that should be done. So do you want a distributed storage, or you want a storage that will not be distributed? When I say distributed, I mean it means something like your data will be stored across different locations, probably different physical locations in real time. So we are not talking about storing your entire data in one location, then um, replicating that data in another location. That's not really what we're talking about. We are talking about, let's say we have data for one item is stored in one place, data for another is in another place. So it's kind of like distributed, scattered across different locations. Then are you looking at a document-oriented kind of storage, or you want a table format like how we have in SQL, or you even want a key value pairs? You want it in key value pairs? Do you want a relational database or a non-relational database? We are talking about relational, we are talking about having foreign keys, relationship between tables. Do you want it to be structured or unstructured? So for each of these categories, there are examples of databases or um, storage architectures around them. Do you want SQL or no SQL? Do you want an in-memory type of storage or non-memory type of storage? Do you want a fully managed database service, or you want to be responsible for its management? So there are many considerations that can be made around this. And one type of storage that is very common in Microsoft Azure environment, which is even custom to Microsoft, is Cosmos DB. And I like to look at this table storage as having a strong relationship with what we have in Cosmos DB. So let me go to my, let's look at the documentation. Okay, so before we even look at what .NET has to offer around um, Azure Tables Client Library, so let me just give um, um, let's just work on this portal so that we'll see things in clearer terms. So this is my storage account. Previously, we were going to containers, that's for blob storage, but this time around, we are not going to go to containers. I thought I had deleted these two. I don't need them anymore. Let me quickly delete it. Okay. So, yeah, so I've deleted that. So I want to work with table storage from this same storage account. So you can see the four categories here: containers, file share, queues, and tables. So I'm going to table. So I want to create a new table. So let me create what can I create? Let me create a table for, let's say, country. Let's say country. Yeah, country. So as you can see, I can't click on it over here. You can see we have a unique URL for it. The storage account .table.core.windows.net/country. In the case of our blob storage, rather than have table here, what we used to have was blob, and also we use the storage account. So I will scroll up, I will go to my storage browser. I'll go to my storage browser. Then I also have blob containers, file share, queues, and table here. But in this case, I would click on tables because that's what I want to work on now. Then I have my table here. I can also create tables here also. So I would click on the country. So the way this table works, as I said earlier on, it's a NoSQL type of database, type of storage rather. So let me see if I can open Microsoft documentation for table storage. I don't know if I have one opened. Okay. Yeah, so basically, as I said, is NoSQL, is non-relational, it uses attributes and values, it doesn't have a schema design, and I think those are just the key things you need to pick from it. So now, unlike the likes of MySQL and SQL Server, that when we are talking about that, we would be looking at fields and records arranged as rows and columns. But in this case, we are looking at entities. So I want to add a new entity now. I'm adding a new entity, and I would be adding properties and values. So you can see the pair over here. We have properties and values. By default, we have two properties already created for us. All we need to do is add a value for them. So this table is called country, and each of these entities are like, let's say for the first entity, let's have a country in mind. Let's say Nigeria. So for my partition key is just something that will differentiate this entity from another entity. So I can use Nigeria as the value. Then the row key is just something that uniquely identify this particular entity. So I can use 001 because it's the first um entity I'm adding. And you can have multiple entities. We can have multiple properties in an entity. So let me add another property. And this time let me call this, because we are looking at countries now. The president can be a property name. So let me call this property name country president, or let me just use president. There's no need adding country. President, and over here, the president for Nigeria, Tinubu. So that's a property and its value. So let me just try to make this very simple. We can choose multiple data types here. Where I'm going with string. So let me insert this. So we have Nigeria. As I said, partition key is what differentiates this from another entity. I'll be adding another entity now. Why the row key is a unique identifier. So let me add another one. So for this one, let me have United States in mind. So for the partition key, I will call this, let me use US. For the row key 002, because this is the second entity I'm adding. Then for the president, Donald Trump as the president. So I'm inserting this. So I can even add another. So let me add another property, and I'll call this capital. And over here, the value Washington, DC. So even though in the initial property, in the initial entity, I didn't have capital, but because it's not structured, it's not really structured, that is allowed. Yeah, so we can see that we've had, this is the first entity, this is the second entity. So we can just work with two. So as I said, the partition key is separating this from this. You can have multiple entities within a table. You can also have multiple properties within an entity. So for now, let's put a pause over here, and we will be going to our Visual Studio to see how we can do some of these things from Visual Studio. But before we go to Visual Studio, let me just show you the Microsoft documentation that I literally got my codes from. So this is the page that I went through this page, and I followed everything that was done here. And that was how I was able to do this from Visual Studio, at least the first, this particular first lab. So I use my command prompt, or probably you can also do it from your Visual Studio to add the packages, the library that we are working with. And the library we are working with is azure.data.tables. Then we added the storage account. Then this is where the interesting part started. So we used our table service client. So I think let me just go to Visual Studio so that we'll see everything being put together. But I would add this link to the description so that you can also use it. So I believe you can see my Visual Studio now. So basically, these are the two libraries that I added to um my Visual Studio projects. Then a couple of static um variables I added here. So storage URI, I got it from the Azure portal. Then also the account name is just the name of the storage account. And the storage account key, you get it from the connection string. So there's a part of the connection string that is account key. So that was where I got this from. Then the table name can be what you want your table to be called. So this can be anything. So I'm using customers now. So, in the one I did from Azure portal, I called it, what did I call it? I called it countries. I called it country, but over here, I'm calling it customer. So I want to create another one for customer. Then we declare our service clients. If you can recall, when we were working with the blob storage, we were using blob service clients. But in this case, because we are working with um table storage, so we are using our table service client. You can see the constructor is called table service client. Then we added our URI, which is from what we have up there, and also some of the details from our connection string. Then this is where we are actually doing the action. We are using table item to call. We are using table item to call our object service clients. Then we are now using that object to access the method create table if not exist. So if the table doesn't exist, we create the table and we are passing a parameter which is table name. So and that has been declared. So let me just run it. It's a very simple code. This all we are doing here is to create the table, and we'll see if that works. Then we have an output line that says table created. Let me run it and I'll share my output screen. Then we'll go and check from the portal if it was truly created. Let me share my output screen. Yeah, so the table has been created. You can see the created table name is customers, table created. Yeah, so let's now let's confirm that our table was truly created. Let's go to our portal. And let's go to tables. So you can see we have another table here called customers, and it was not created from our Azure portal. It was created from our Visual Studio. If I should scroll up to where we have our storage browser and we see our tables, you can see it's also here and it's definitely empty. If I should click on it, no items, there are no attributes, there are no properties, and there are no values. So it's still empty. We'll be working with this later on. So I think with this is a good introductory video for table storage. As I said earlier on, when you think table storage, don't have the SQL tables. Don't allow the SQL tables confuse you, because in actual facts, table storage is actually no SQL. It's actually no SQL. And for you to know, so if you want to know the type of database that best suits what you are doing, it's even more similar to Cosmos DB than the traditional SQL-based database. So I want to show, there's a link I used to use for Microsoft that tells you in detail some of the options you have when it comes to databases. So I'll be sharing it now. Yeah. So you can see different categories of database and what they are best for. So you can see Cosmos DB, fast distributed, NoSQL. So just like our table storage is also NoSQL. It's used to deliver real-time, high quality, blah, blah, blah. And you can see what SQL database is best for. Then if you scroll down, you can see what some of the open source databases are best for. Then if you should scroll down, you can see the likes of Redis and Memcache and some of all these things. This might not be sufficient because this is only outlining some of the databases um, that are peculiar to that you can use in Microsoft's based environment. But I know that on AWS there are a couple of other interesting databases that does so for example Aurora, Amazon Aurora is one great database that is also cloud-based and relational. I think it's Amazon answer to Microsoft's Cosmos DB. Then we have Redshift, which is also by Amazon, and that's great for data warehousing, big data kind of storage. And we also have Amazon Dynamo. No, I think Amazon Dynamo is even more closer to Cosmos DB. So Amazon Dynamo is also distributed, NoSQL, key value, and the like. So you just need to know what you are looking for and know how to use what you are looking for. But basically, what I think you should be looking at, the categorization that I think are really keys: distributed versus non-distributed, document-oriented versus table versus key value pairs, relational versus non-relational, structured versus unstructured, SQL versus no SQL. So there are two categories of NoSQL. There's the SQL that is saying that that NoSQL or limited structuring. There's also a NoSQL that is saying that not only SQL. So in addition to SQL, it can do more. Then also there's in-memory storage versus non-memory, which is great for application caching. Then there's fully managed, the ones that you want your cloud service provider to manage for you, or the one that you want to be responsible for managing. So I think that's just about 8 different categories that I brought up. There are still more. Something you should do. And also, I didn't even mention the ones for big data and data warehousing. So we'll be putting a stop to this lab here. Hopefully you find it informative. Have a great day.